launch.
This hearing will come to order. Without objection, the chair is authorized to declare a recess at any time. And before delivering my opening remarks, I wanted to note that today the committee is meeting virtually. I want to announce a couple of reminders to the members about the conduct of this meeting. First, members should keep their video feed on as long as they are present in the hearing. Members are responsible for their own microphones, but also please keep your microphone muted unless you're speaking. And finally, if members have documents they wish to submit for the record, please email them to the committee clerk, whose email address was circulated prior to the hearing. So good morning. Welcome to today's hearing on NASA's Earth Science and Climate Change activities, current roles and future opportunities. And first, I want to thank our panel of expert witnesses for being here. There's no more important time for addressing climate change and the health of our planet. Delaying action risks everything, from increased exposure to heat waves, spread of vector-borne diseases, drought, crop failures, and severe weather. Actions taken and policies developed to respond to the climate crisis must be informed by peer-reviewed science. And that science starts with measurements, observations, and research that leads to understanding. That's where NASA comes in. But studying the Earth, space is the ultimate vantage point. And thanks to NASA's fleet of space-based science observations and measurements, we have long-term research data sets that show the scientific signals of climate change. Those signals, unlike short-term variations in terrestrial weather, change over longer periods of time. NASA Earth observation measurements also provide important inputs to models that enable our ability to predict and forecast climate change. And NASA satellite measurements contribute to studies such as the National Climate Assessment, a scientific assessment of climate change and its impacts across the United States. Beyond the data, satellite observations have the ability to tell a compelling visual story, such as the significant loss of sea ice and glacier melt in the Arctic. Several astronauts have remarked on their experiences of viewing the Earth from space. In a Scientific American article issued just a few days ago, former NASA astronaut Scott Kelly said, quote, "During my first mission in 1999 to fix the Hubble Space Telescope, I remember passing over South America and being awed by the sheer size of the Amazon rainforest. But on my last mission in 2016, only 17 years later, burning and clear cutting were clearly evident. After seeing the Earth dramatically change from this unique perspective, I firmly believe that solving climate change is the moonshot of the 21st century." End quote. Closer to home, NASA satellite data are helping identify algal blooms, and NASA and NOAA satellite data are helping farmers increase their efficient use of water resources for irrigation, saving money and increasing profitability. These are just a few examples that illustrate the value of NASA's Earth science research to business, local resource managers, and environmental decision makers. NASA once referred to its Earth science activities as mission to planet Earth. In the midst of economic, property, health, and environmental impacts from climate change, it's clear we have an urgent mission before us. We need to look at every opportunity to act now. Is there more that NASA could and should do? Are there gaps in our scientific understanding of the Earth system that need to be addressed? Are there opportunities to expand the transition of research into information tools? And of course, it's not just NASA. Other federal research agencies are working on climate change research and mitigation efforts. Commercial satellite imaging companies, philanthropists, and not-for-profit entities are ready and willing to contribute to the climate challenge. And we need them all. Where and how do they fit into an overall climate strategy? How should NASA effectively partner with non-federal entities and also maintain free and open data? In closing, the nation is planning aggressive efforts to mitigate the climate crisis, and we'll need to check our progress. While NASA is not a regulatory agency, certainly not the carbon police, how can space-based measurements validate or check the effectiveness of mitigation strategies? Where does NASA play a role? Today's hearing is an important opportunity to consider these and other questions, and I really look forward to hearing from our distinguished witnesses. So talking about distinguished, let me turn to our ranking member, the gentleman from Texas, my friend, Dr. Brian Babin, for his opening statement. Dr. Babin. And Brian, you are still muted for the moment.
How about now, Mr. Chairman? Can you hear me?
You're good. Thank you.
Okay.
Yeah, thank you very much. Great to be with you. Looking forward to this hearing. It's particularly timely. The Biden administration proposed increasing NASA's Earth science budget by $300 million, which is a 12.5% increase above fiscal year 21 enacted levels. Since we don't have other details about the proposed budget yet, we do not know what impact this proposal will have on other aspects of the agency or how the agency is proposing to spend this increase. While those details may be lacking at this moment, there are a number of other initiatives currently underway at NASA that we can certainly explore. For example, NASA received the second Earth Science Decadal Review from the National Academies in 2018. This hearing is a great opportunity to understand how NASA is responding to that report. Previous decadal surveys highlighted NASA's unique role of developing first-of-a-kind instruments that could then be transitioned to operational agencies like NOAA and USGS. As NASA seeks to take on a more operational role in maintaining observational data sets, it will be important for Congress to understand the long-term impacts of this evolution on other Earth science missions, on other science divisions, on other elements of the agency like human exploration, as well as the effects on the government and society as a whole. Maintaining a balanced and sustainable portfolio of programs at NASA could insulate specific programs from wild swings in funding that complicate planning and operations. One way that NASA can take on these new operational roles without breaking the bank or impacting other programs is to leverage the existing commercial remote sensing industry. Previous attempts to incorporate commercial data were met with resistance from the government, and the industry was still in its infancy at that time. The commercial remote industry is much more robust today, and agencies are much more receptive to incorporating data from novel sources. NASA initiated a data buy pilot project in 2017 and more recently stood up a formal data acquisition program. One near-term decision relating to leveraging the commercial remote sensing industry is Landsat. The Landsat program has provided world-class, multi-decade, 30-meter resolution of Earth's surface. Last year, the administration announced that it was undertaking a Landsat architecture study to explore novel ways to maintain the Landsat data set. As the former director of USGS stated at the time, quote, rather than one single large satellite bus, which is what Landsat has been historically, we've looked at other options. The revolution in space is underway, and we'll want to capitalize on that as much as we possibly can, unquote. Despite progress made towards this effort over the last several years, NASA issued a request for information, an RFI, for Landsat next instrument studies that may deviate from this plan and return a business as usual approach. U.S. law and national policy directs NASA to advance the commercial space sector. Title 51 of the U.S. Code direct NASA to seek and encourage to the maximum extent possible the fullest commercial use of space. NASA is also directed to acquire, where cost-effective, space-based and airborne Earth remote sensing data, services, distribution, and applications from a commercial provider. Both the 2014 National Plan for Civil Earth Observations and the 2015 National Space Weather Action Plan direct federal agencies to identify and pursue commercial solutions. More recently, the 2019 National Plan for Civil Earth Observations directed agencies to strive to engage with the full Earth observations enterprise to determine whether there is a commercial solution available or in process that might be more appropriate than creation of a new federal observing asset. These policies were also reinforced in the most recent decadal survey for Earth science. I look very much forward to discussing how NASA plans to incorporate commercial remote sensing data to maximize taxpayer dollars spent on Earth science. So thank you, and I yield back the balance of my time. Thank you, Mr. Chairman.
Dr. Babbitt, thank you very much. I really appreciate your insights.
Yes,
and
sir.
now let me recognize the ranking member of the full Science Committee. It's Chairman Emeritus, Mr. Lucas from Oklahoma.
Thank you for holding this hearing, Mr. Chairman. Today's hearing is an important opportunity for the committee to engage in oversight of NASA's current and future Earth science and climate activities. I'm looking forward to discussing how the agency can best utilize resources within existing budgets and how it can use additional resources. NASA's mandate to research Earth's atmosphere dates back to the passage of NASA's Organic Act in 1958, which stated NASA shall seek the expansion of human knowledge of phenomena in the atmosphere and space. That mission has evolved through the decades as our technical capacity and scientific knowledge have increased. Today, the Earth Science Division of NASA oversees a broad range of activities and missions, including managing a variety of ongoing Earth observation missions, planning future missions, and sharing the data collected from these missions with the scientific community and the public. NASA is currently operating more than a dozen Earth science missions in tandem with international partners and other federal agencies, and has a dozen more missions slated to launch in the decade ahead. These missions provide a new generation of satellites and instruments to monitor and provide data about Earth's changing climate and the scientific community. Today's hearing represents an opportunity to evaluate NASA's Earth science and climate partnerships within the federal government, with international partners, and with the private sector. This committee has an opportunity and an obligation to consider whether these partnerships work in the most effective manner and if the agency would benefit from new approaches to these partnerships. Our panel represents a cross-section of government, the nonprofit sector, and industry, and that is appropriate as all three sectors must work together to provide the best knowledge to the scientific community. Today's hearing is timely. The commercial remote sensing industry has come a long way in a very short period of time. New remote sensing technologies have made images of Earth more accessible. The images and data made available by commercial providers are of great value to any number of consumers, whether it's in the public safety officials, in the West managing forest, or farmers in Oklahoma growing crops. As the author of NOAA's Commercial Weather Data Buy Program and the Commercial Data Buy Program in the space weather legislation passed last Congress, I have long championed the ability of commercial remote sensing industry to fill gaps in the federal Earth observation abilities. To be clear, this does not mean that the commercial sector would replace the government's role, but instead complement it and provide more cost-effective and novel solutions. We'll hear testimony today about how the commercial sector is helping fill this need, as well as how NASA could increase its utilization. I look forward and thank our witnesses today for sharing their perspectives on this topic. And I expect a productive discussion about how this community can ensure NASA's Earth science and climate activities can be made even more efficient and cost-effective moving forward. Again, Mr. Chairman, I thank you for the hearing, and I yield back the balance of my time.
Thank you, Ranking Member Lucas, very much. This time I'd like to introduce our witnesses. Our first witness is Dr. Karen St. Germain. Dr. St. Germain is the Division Director for NASA's Earth Science Division within the Science Mission Directorate. Dr. St. Germain received a Bachelor of Science degree in Electrical Engineering from Union College and a Doctor of Philosophy degree in Electrical Engineering from the University of Massachusetts. So welcome, Dr. St. Germain. Our second witness is Dr. Gavin Schmidt, Acting Senior Advisor on Climate Science to the NASA Administrator and the Director of the Goddard Institute for Space Studies. Dr. Schmidt received a first-class Bachelor of Arts degree in Mathematics from Oxford University and a doctorate on the calculation, scattering, and stability of topographic Rossby waves from University College London. I hope you're going to talk about those scattering and stability. So welcome, Dr. Schmidt. Our third witness is Mr. Riley Duren, a research scientist at the University of Arizona and Chief Executive Officer of the Carbon Mapper nonprofit organization. He also maintains a part-time appointment as an engineering fellow at NASA's Jet Propulsion Laboratory. Mr. Duren received a Bachelor of Science in Electrical Engineering from Auburn University. Welcome, Mr. Duren. Our final witness is Mr. Robbie Schingler, an entrepreneur, co-founder of Planet Labs, and a former NASA engineer and program manager with more than 20 years of experience building satellite projects. Mr. Schingler received a Bachelor of Science in Engineering Physics from Santa Clara University, a Master of Science in Space Studies from International Space University, and a Master of Business Administration from Georgetown University. Welcome, Mr. Schingler. So we will start in the order just introduced. Dr. St. Germain, the floor is yours for your opening statement.
Chairman Beyer, Ranking Member Babin, members of the subcommittee, thank you so much for the opportunity to speak today on NASA's contributions as a global leader in Earth science. NASA holds a unique position as the only space agency with integrated end-to-end Earth observing capability, from building and flying satellites to research, data systems, and delivery of science applications. Today, I'll testify on how NASA's Earth science expertise advances our understanding of how to adapt to and ultimately thrive on our changing planet. The science of the last 20 years has settled the question of whether our planet's climate is changing. What we must do over the coming 20 years is to better understand Earth systems, those interactions between land, ocean, air, and ice, and human communities, so we can improve our predictions of how our environment might change. Those predictions are essential for policymakers, such as this committee, to make decisions on mitigation, adaptation, and resilience. There is no better vantage point than space to collect the Earth data that is the foundation of our science, our models, and our predictive capability. Today, NASA flies 23 space-based observing systems in addition to the satellites we build for our partner agencies, USGS and NOAA. NASA systems measure greenhouse gases and sea level rise. They monitor fire weather and detect soil moisture and crop stress, just to name a few. We combine our observations with data from our strategic partners and commercial Earth observation companies to investigate complex questions that lay the foundation for modeling, prediction, and scientifically sound information. This is important because these are the models and information products that inform decision makers at every level on imperatives like ensuring a safe and ample supply of drinking water, maintaining our nation's ability to feed itself, and building community resilience and safety from extreme weather events. To meet this demand for information, NASA Earth Science is accelerating work in three key areas: observations, modeling and informatics, and applications and dissemination. I'm going to touch on each of these areas briefly. NASA is advancing observations capabilities by investing in technology innovation, exploring alternative observation platforms, new approaches to industry partnership and commercial services, and expanding collaboration with our international partners. And I'll say more about those specific plans in just a moment. Modeling and informatics further our understanding and prediction of the whole Earth system by extracting scientific understanding from the measurements and capturing that understanding in models and frameworks that span timescales from minutes to decades and spatial scales ranging from continents to individual agricultural fields. Finally, in applications and dissemination, we're dramatically accelerating the delivery and use of scientific understanding. We're working through open science and accessibility principles to ensure our data and information are within reach, especially to previously underserved communities. And we are creating scalable science applications to meet the needs at every level of decision-making. Returning to the topic of NASA's space-based observation capability, the National Academies of Science laid out an ambitious but critical observation objectives in its 2017 Earth Science Decadal Survey. NASA intends to meet those objectives through an array of space-based satellites, instruments, and missions that we're calling the Earth System Observatory. These measurements will help us answer critical open questions about the Earth system. We'll observe aerosols in our atmosphere and how they interact with clouds, convection, and precipitation to tackle the largest natural uncertainty in predicting climate change, while improving severe weather and air quality forecasting. We'll track minute local changes in our Earth's mass, which will inform drought predictions and help local water managers make decisions about agricultural and municipal water supplies. And our surface biology and geology observations will improve our understanding of how climate change affects food production and ecosystems. Finally, by monitoring changes in our Earth's surface, we will better predict sea level rise and events such as earthquakes, volcanoes, and landslides. Together, these observations will capture a three-dimensional view of our Earth from atmosphere to bedrock. And we're now starting the first phase of mission planning. NASA is advancing not just what we're doing, but how we're doing it. We're dedicated to open science and diversity, more partnership with the commercial sector, and new business models to rapidly onboard advances in technology. Around the end of this decade, almost another billion people will live on our planet, putting more pressure on Earth's resources and increasing demand for actionable information. Climate change demands science equal to the challenge it presents. NASA is moving to meet this challenge, accelerating our science, our international and interagency partnerships, and exploring new ways to do business. Thank you for the opportunity to discuss NASA's Earth Science program, and I'd be pleased to respond to any questions you might have.
Thank you very much, Dr. St. Germain. We will have plenty of questions for you, I'm sure. Now let me recognize Dr. Gavin Schmidt for his testimony.
Chairman Beyer, Ranking Member Babin, members of the subcommittee. My name is Gavin Schmidt, and I am the Director of the NASA Goddard Institute for Space Studies and the Acting Senior Advisor on Climate to the NASA Administrator. Today, I would like to share with you the breadth and depth of NASA's work on climate, covering pure scientific research, technology development, applied science, education, as well as the efforts to reduce the agency's own emissions and build greater resilience. NASA is the lead agency for civil aeronautics research and for scientific research that can be productively studied from space, acknowledging that practical benefits for society are always an important measure of success. NASA is specifically tasked with ensuring public access to accurate data on global warming. Since the late 19th century, global surface temperatures have risen more than 1 degree Celsius, 2 degrees Fahrenheit. Sea level has risen by about 12 inches since 1900 and 3 millimeters per year right now. These broad changes are already having a direct impact on communities in the United States and internationally. We track most of the factors driving climate change and investigate the processes that underlie the emergent patterns of climate variability. My colleague, Dr. Karen St. Germain, has already expanded on these topics in her testimony today. Research connections on climate also include NASA's Heliophysics Division and the Planetary Science Division under the broad umbrella of astrobiology. NASA's climate portfolio also encompasses research into sustainable aviation and space technology transfer focused on clean energy and environmental monitoring. NASA is investing in industry partnerships that will develop the next generation of single-aisle aircraft that will be at least 25% more fuel efficient by the early 2030s. We will award contracts for the first ever high-power hybrid electric propulsion system for large transport aircraft by the end of summer 2021, with flight demonstrations of an electrified powertrain expected as early as 2023. NASA is also providing solutions to the challenge of all-electric flight through development and flight tests of the X-57 airplane. A 2018 competition developed in partnership with the Robert Wood Johnson Foundation focused on an aerosol monitor that could be used both on the International Space Station and in urban polluted environments. Another NASA prize competition, the CO2 Conversion Challenge, seeks to create a carbon neutral manufacturing system that can be used in space as well as on Earth. NASA has partnered with local government entities. For instance, in New York, NASA input into the city's climate change panel has been important in helping set new standards and planning guidelines. NASA also partners with other agencies such as the Department of Energy and NOAA and through the US GCRP to help coordinate global change research across the federal government. NASA is participating in the White House's National Climate Task Force and the Climate Innovation Working Group. Internationally, NASA has partnerships with space agencies across the world to develop, launch, and maintain platforms and instruments for long-term climate data. NASA's GLOBE and AeroNet programs and SERVIR, a joint NASA and USAID initiative, collectively have a presence in nearly 125 countries. NASA recognizes that rising sea levels and an increase in hurricane activity along the Gulf Coast will have significant impacts on our ability to fulfill our mission, and that we must implement protective measures in order to reduce our risks. Center master plans now include sustainability as a key goal. And since 2008, NASA has seen a consistent downward trend in its own greenhouse gas emissions. For education and outreach, NASA's Science Activation Program enables NASA science and experts and content to engage learners of all ages. NASA reaches upper elementary age children through climatekids.nasa.gov, while climate.nasa.gov is a top public website with almost 10 million annual visitors. Recently, NASA has convened a climate strategy working group to develop a more integrated approach to the agency's climate portfolio and to address the administration's priority for a government-wide approach in response to the climate crisis. Additionally, we are creating a climate action plan to further build resilience and educate management on the need to embed climate change mitigation and adaptation into our decision-making procedures. NASA has long recognized that climate science is a fundamental part of our mandate. With the increasing evidence for serious impacts and the elevation of this topic by the administration, it is time for a renewed focus on all aspects of climate change and a commitment to ensure that this data and understanding will continue to accumulate and be used for the benefit of society. Thank you very much.
Dr. Schmidt, thank you very much. Now let me recognize Mr. Riley Duren for your testimony.
Thank you, Chair Beyer, Ranking Member Babin, and members of the subcommittee. I appreciate the opportunity to contribute today. This is really an important discussion. And I'll start by saying that simply by convening this hearing, you're already taking, I think, an important step in highlighting a persistent gap in U.S. climate policy discussions. Satellite observations and data in general are critical, not only for basic climate research, but also enabling science-based decision-making by a broad cross-section of society. So NASA and its partners absolutely belong in these discussions, and thank you for highlighting this topic. As lawmakers consider investments in the nation's physical infrastructure, it's also important to recognize the urgent need to address gaps in critical data infrastructure that can inform efforts to minimize climate impacts and improve overall environmental resiliency in the US and globally. As an example of data gaps and opportunities for improvement in closing them, I'd like to describe a new public-private partnership that's leveraging NASA science and technology to deploy a global decision support system for quantifying, tracking, and supporting mitigation of greenhouse gas emissions. In recent years, there has been a growing number of public and private sector actors that have signaled an interest in reducing their methane and carbon dioxide emissions, including ambitious decarbonization targets by some of the world's leading economies and major oil and gas companies. Multiple field studies over the years by many groups have conclusively identified the existence of so-called methane superemitters, where a relatively small fraction of the infrastructure is responsible for a disproportionate amount of emissions. So my own NASA-funded research team used advanced remote sensing aircraft to conduct the first comprehensive economy-wide survey of methane emissions in California. We found that less than 0.2% of the infrastructure in the state is responsible for over a third of California's entire methane inventory. Many of these super emitters are highly intermittent, and they're widely dispersed over the landscape, and they're difficult to find typically with conventional surface measurements. If you can cue the movie, please. Great, thanks. So our recent airborne surveys with NASA aircraft over the Permian oil and gas basin and other regions around the US add to this body of evidence. What you're seeing here is a false color movie taken from a NASA aircraft at 18,000 feet, looking at methane plumes. And this offers a vivid illustration. These super emitters are broadly distributed across the landscape, almost like invisible wildfires. And they mostly go unseen, even by operators who were otherwise motivated to fix leaks to avoid product loss. So oil and gas companies that have reviewed our data indicate that at least half of the methane super emitters we're detecting are the result of leaks and malfunctions that were previously unknown. So this suggests low-hanging fruit, if you will, for near-term progress. The idea here is that a high-fidelity constellation of satellites could offer daily facility-scale methane monitoring over key regions globally to alert operators and regulators of leaks for more timely and cost-effective repairs. However, in practice, this means confronting both technical and institutional barriers. No single organization today has the mandate, resources, or even the culture to field this kind of decision support system, at least not quickly or affordably at scale. In this case, the challenges are the necessary remote sensing technology is currently unavailable outside of NASA. NASA itself lacks the capacity to launch large constellations of satellites. There's no existing government program to finance the build out of such a system. Sustaining these systems once you establish them is difficult, given shifting federal priorities, and purely commercial services may lack the transparency needed for global public trust and adoption. So to confront these challenges, we've established a new nonprofit organization called Carbon Mapper, and a public-private partnership that includes remote sensing technology transfer from NASA's Jet Propulsion Lab Planet's agile aerospace approach to deploying constellations, science leadership from the University of Arizona and ASU, policy expertise and data transparency enabled through California and our nonprofit partners, all powered by philanthropy. Philanthropy is paying for the start of this program. I know I speak for other partners in thanking Dr. St. Germain from NASA and Mr. Schingler from Planet and their teams for their vision, support in establishing this program. And in closing, effective responses to climate change and other environmental challenges require action by a cross-section of society, including governments, businesses, and private citizens. The same applies to generating robust data and shared awareness to inform those actions. We don't have time as a species for delayed action or false starts because of incomplete data or monolithic approaches. We need the best possible science and systems engineering creativity of organizations like NASA to enable new innovative efforts to deliver actionable climate data. And we need the help of Congress in helping us support and recognize these efforts. Thank you very much.
Mr. Duren, thank you very much. We really appreciate that. Fascinating overview. And now let me recognize our final witness, Mr. Schingler, for your testimony.
Chairman Byer, Ranking Member Babin, Chairwoman Johnson, Ranking Member Lucas, and members of the subcommittee, I'm honored to appear before you today to discuss the important role that commercial companies are playing in supporting NASA's Earth Science and Climate Change mission and the opportunities NASA has to better leverage the commercial enterprise to meet their scientific and climate goals. I had the privilege to join NASA during my undergraduate studies. It forged my professional life with 9 years of service that set the conditions for my founding role at Planet. I'm proud to be inspired, trained, and influenced by NASA. Now, everyone knows the big new rockets being developed today, but few people are aware of the renaissance occurring in satellites that orbit our planet. It's a bit like the transition from the mainframe computer to the desktop computer, putting the power of knowledge about the Earth into the hands of more of society. And over the last decade, this has resulted in a 1,000-fold increase in capability per dollar. This dramatic improvement means more data for more applications. For example, Planet captures an image of the entire land mass of the Earth every day, powered by the world's largest constellation of Earth observation satellites in history. This data set accelerates our understanding of land use change, biodiversity, and climate science, while also helping farmers increase agricultural yield, companies monitor supply chains, and governments prepare for and respond to natural disasters. I'm convinced that only the American market-based risk capital ecosystem could create Planet 10 years ago. Congress and this committee has been instrumental in that proud history. Given the urgency to make strides in climate science, the benefit of massive investment from capital markets in the satellite industry, combined with innovation and a lasting foundation of US government systems, I'm confident we can work together to make an even brighter future. To that end, I respectfully offer a few recommendations for your consideration. This committee can support NASA and the commercial US remote sensing sector by bringing the commercial small sat data acquisition program into statute in the next NASA authorization bill. In 2017, under the leadership of Thomas Zurbuchen, NASA, OMB, and Congress saw the potential value that US commercial remote sensing companies could bring to Earth and climate scientists. They set out to understand the scientific viability of these new data sets, and it led to the commercial small sat data acquisition program. This is a huge success from my perspective, and NASA is actively bringing on new commercial companies and expanding the scientific user community with federal civilian agencies. Investments in commercial remote sensing capabilities fused with government-operated sensors drive innovation, power job creation, and lead US universities and research centers on a path to excellence. I urge this committee to bring in the commercial smallsat data acquisition program into statute in the next NASA authorization bill and robustly fund the program to reflect the growth and value it is demonstrating within the scientific community. As NASA is creating their next flagship missions, including the Landsat Next program, NASA should incorporate the planned viable commercial capabilities into their procurement strategies and see commercial capabilities as a forethought rather than an afterthought. Now, let me be clear. Commercial constellations do not replace national systems. They complement, improve, and enable national systems to more affordably push the scientific frontiers. When there are reliable commercial Earth observation systems, the national systems can stretch even further to enhance our understanding of the planet. Finally, we advocate for a whole of civil government approach to commercial data buys. Embrace a whole of civil government approach to making scientifically accurate and factual Earth observation data available. Put another way, you can't manage what you can't measure. And this community has the information to bring us to a common operating picture to better manage our society. These efforts to purchase commercial data for both scientific and operational use cases across all civilian agencies could be led by NASA in partnership with NOAA and USGS. So as I conclude, allow me to thank the committee for including a voice from the US commercial sector in this important hearing. As Congress and the Biden administration look to focus on climate programs, this conversation is well-timed to highlight the important role that remote sensing satellites, both national assets and commercial constellations, have in providing the data needed to empower better decisions by federal agencies, state and local governments, communities, companies, and individuals. Planet is a committed partner to NASA and will provide innovative commercial services to equip America's Earth-observing community with the tools to lead in this increasingly competitive international landscape. You can be confident, as I am, that US remote sensing companies deliver new data sets and novel tools to enable governments, societies, and businesses to make better decisions and guide humanity toward a more secure and sustainable future. Thank you, and I look forward to your questions in our exciting future ahead.
Mr. Schingler, thank you very much. All fascinating. And now we'll begin our round of questions. I get to go first by virtue of this chairmanship. So let me begin with Dr. St. Germain. We just heard from both Mr. Duren and Mr. Schingler about all this happening on the commercial side in terms of data. Planet having more satellites tracking what's going on Earth than anyone else. How do you feel about, and what are your thoughts about this ever-growing possible partnership between our public NASA and our commercial companies?
Thank you for the question. I couldn't be more excited. Just muted. There we go. I think we're back. I couldn't be more excited about the possibilities enabled by all of the growth in commercial Earth observation in both directions. I think, as Robbie said, the capabilities that the commercial sector is bringing to science are very exciting. They absolutely complement our government systems, and they expand the scope of the science we can do. And in the other direction, Riley talked about bringing NASA technology out into the commercial sector to enable future commercial capabilities. And I think that is just as exciting. So I'm thrilled and really looking forward in this position to exploring new ways of partnering with the commercial sector. Thank you.
Great, thank you. And Riley, you talked about the super emitters, the methane with that very great flyover, and that only a third of these, 0.2% of the infrastructure is responsible for a third of the state's methane emission. How does that compare to the other greenhouse gas emission from transportation, from buildings, from manufacturing? Is methane just a tiny piece of this, or if you can fix those flares, can you make a significant difference?
Yeah, great question. What I like to say about greenhouse gases, like many things on the planet, is it's a mixed bag. Methane tends to be leaky in the way it manifests. And the best way I can describe it is if you have a sprinkler system in your yard, you're eventually going to have a leak. That doesn't mean that the sprinklers are necessarily spraying water all over the place, but when it happens, you find out when you look at your water bill, if you're lucky, you see the geysers shooting up, in the front yard. So that tends to be the nature of methane associated with human activity, whether it's the energy sector, the waste management sector, or even agriculture. It tends to be very leaky, and therefore it can occur randomly, and it's difficult to predict. That's different, generally speaking, than some of the other greenhouse gas emissions, but in particular CO2 emissions from the transportation sector. Imagine that being spread out over freeway systems or through other transportation vehicles. And so I guess what I would say is your mileage varies, so to speak, and it's very different by sector. And the technology I talked about addresses one part of the greenhouse gas monitoring challenge. It really focuses on these leaky point sources for methane and CO2, for example, stationary power plants. We need a broader constellation of systems, or system of systems, as we like to say in NASA system engineering world, to address the full landscape. And that's part of what we have between what we talked about with Carbon Mapper, NASA's existing program, and programs with other international space agencies, as well as commercial actors with instruments on the ground, not just space.
Cool, very cool, thanks. Mr. Schingler, you talked about NASA's Commercial Small Sat Data Acquisition Program. As you probably know, the Senate folded NASA's reauthorization into its Endless Frontiers Act last week. Did that include the Small Sat Data Acquisition Program?
To my knowledge, Chairman, that does not include the NASA's Small Sat Data Acquisition Program in its current form.
So we still have ways to go. Okay, great. Because we're about, hopefully later this year, we will take up NASA reauthorization. And then Dr. Schmidt, one of the things you talked about was the many, many different players you have. And in your new role on the Climate Task Force, how do you coordinate all these people that want to be part of providing information on climate change in this?
Thank you very much for the question. Yes, no, that's a real challenge, and as I've stepped into this new role, that has really been the dominant theme of what we've been doing. We've been bringing together all of the people who are working with external partners, and we're trying to collate that information, and we're going to make that more visible, and then we'll be able to see, I think, where the gaps are, where the successes are, and where we may be able to roll out a broader use of the information and data that NASA provides.
It sounds like the invasion of Normandy, but good luck. So,
thank you.
Well, my time is up. Let me now recognize our ranking member, Dr. Brian Babin.
Okay, thank you very much, Chairman Beyer. I want to say thank you to our witnesses as well. Appreciate you being here. Mr. Schingler, your testimony highlights issues with the Landsat architecture and a recent instrument study pre-solicitation. Please allow me to read from your testimony. Unfortunately, the commercial community is receiving mixed messages from the Landsat Next program at NASA and USGS. Recently, material and unexplained changes and inconsistencies between the Landsat Next instrument study pre-solicitation published on February the 18th, 2021, and the Landsat Next RFI published on October 13th of 2020 suggest that rather than looking for novel new approaches to meet and exceed the Landsat mission requirements, the NASA Landsat Next team has predetermined the constellation and instrument structure for Landsat Next. In the most recent instrument study, NASA included requirements that respondents to the study assume prescribed and specific orbital attitude and minimum swath width that favor a more traditional and expensive architecture toward large satellite designs. Such prescriptive requirements, particularly in the early study, will limit innovation in the Landsat Next architecture, constrain what NASA may learn from the instrument study, and may ultimately restrict the Landsat Next mission to coarser spatial resolution and lower revisit rate. These outcomes are likely to negatively impact the Landsat user community and result in an inefficient use of U.S. taxpayer resources. The effect of such requirements during an instrument study could be to limit the possible responses or offerers and predetermine the instruments and architecture for the Landsat Next system, unquote. Can anything be done, Mr. Schingler, to ensure an unbiased solicitation, or will it require legislative action? Thank you.
Thank you for the question. And I think by highlighting the benefits of what has already happened with NASA on the commercial side, with the Commercial Small Sat Data Program, and the scientific utility that's coming out of that, I think it can better inform the program office in how they come about procuring the next generation systems for Landsat. And for the committee to recognize This is something to be launched later on this decade. We do need to think about 5 years ago what was available and what can be available 5 years from now. As we are seeing also with the European Union Copernicus program and their planned upcoming constellations, we should be thinking about these, as Riley was saying, as a system of systems, which is what are the needed data gaps that allow for these free and open data sources provided by governments to be interoperable with one another. It is no one sensor that is necessary for us to have the data necessary for climate action, but instead, it is something that is about interoperability and looking for reference data sets that other data sources can be available for. And so at this early stage of a procurement strategy, we do urge this committee and NASA and USGS to open up the aperture and to consider more novel and innovative approaches toward the next generation Landsat Next program.
Okay, well, one more question for you, Mr. Schingler. Your testimony also mentions the commercial remote sensing regulatory process. Since you also sit on the advisory committee for commercial remote sensing, what can NASA do to aid the Department of Commerce in the interagency process that reviews new remote sensing technologies? As noted in the last advisory committee meeting, despite the new streamlined regulations, American companies are still forced to be second place in many areas of commercial remote sensing and prohibited from offering anything not on the market without significant, often crippling conditions being placed on their operations. Real quickly, please.
Yes, the Advisory Committee for Commercial Remote Sensing met a couple of weeks ago, and there was an excellent briefing from a National Geospatial Intelligence Agency colleague who articulated a leaderboard across all the remote sensing capabilities globally. And if you played back over time, you could see how other nations are accelerating in taking over leadership for commercial remote sensing capabilities. Last year, NOAA did a great job in shifting a bit of the approach toward regulatory process. There's still more to be done. It should be more than just what is commercially available today, but forecasting where things are going so that American competitiveness can continue to excel in the global marketplace.
Okay, I see my time's expired. I had one for Dr. St. Germain, but we will submit it in writing then. So with that, Mr. Chairman, we will yield back. Thank you.
Dr. Babin, thank you very much. I now recognize the Chair of the House Administration Committee, Ms. Loughran from California.
Thank you, Mr. Chairman, and thanks for this wonderful hearing, which I think is instructive to all of us. Dr. St. Germain, it's my understanding that the Earth Science Division's Applied Sciences program used to have a dedicated wildfire program, wildland fires program, and that had been created because of an identified need, but it was concluded in 2017 because it didn't have enough money to keep going. Now, we have an increasingly prolonged wildfire season in the United States, certainly in my state of California, but not just in California, all over the United States. And we've got devastating wildfires that are being experienced. Is it important or valuable to have dedicated programs to tackle some of our biggest climate challenges and targeted appropriations to support this work, in your judgment?
Thank you for the question. Today, we provide a lot of support for wildfire, both prediction and disaster response. We support that through two of our programs. One, both out of our Applied Sciences program. One is the Ecological Forecasting program, and the other is the Disasters program. And just to give you a sense, in 2020, we supported 6 disasters activations in support of wildfires in the Western U.S. I think there are a number of ways that we can manage these things, and there are always choices, right? And those choices have an impact on the synergies we can take advantage of. I'm always open to looking at alternative ways of managing our programs and continually reevaluating them in the context of their effectiveness.
Well, you all are the scientists, not us. but I'm interested in making sure that we are making the appropriate investments in wildfire R&D work. And if it's not a specialized division, then what other portfolios need to be enhanced? Right now, there are people being evacuated down in the Los Angeles basin. We had, a number of people lost their lives in Paradise, California, in Doug LaMalfa's district last year. So I'm just interested in what needs to be enhanced in terms of prediction. And also, as you probably know, the governor of California just announced a big investment in fuel reduction, but it seems to me that the preventive efforts could be greatly enhanced through this whole observation program. What are your thoughts on that?
Let's see. Today, we work, when in our wildfires work, we work very closely with our interagency partners, NOAA, for example, as well as responders on the ground. We can, as I said, we can always look at ways to do that better. And I'd like to actually give that some thought and take the question for the record and come back to you with some ideas.
I would appreciate that very much, because obviously there's fighting the fires, but this is not, this drought that we have is not it's not a temporary situation. This is a permanent situation. And the steps that we're going to need to take to prevent the catastrophic spread of fires is something that needs to get our attention, not only at a state and county level, but at a federal level. So I would appreciate that advice. And Mr. Chairman, I yield back.
Congresswoman, may I respond to that?
Oh, that would be lovely. Thank you.
Excellent. Yes. So there is a fantastic program that's called the California Forest Observatory that was launched last year. And it is a combination of aerial LiDAR data with Earth observation data from space to then quantify, and weather data to then understand wind patterns and quantify the fuel load. And what this does is it allows for CAL FIRE to be able to understand where the risk is and forecast where things can go. This is just a pilot project as it is right now. It is working and operational, but the technology behind it is scalable to the rest of the country. In addition to that, there are some other government sensors that detect infrared signatures that are extremely useful, not just for national security, which is its primary purpose, but also for understanding fire spread and hotspots. And being able to have that data more easily accessible to our firefighters on the ground is something that would be really welcome.
That's great information. Maybe the two of you can talk after this hearing, and I don't want to abuse my time, Mr. Chairman, so I yield back.
Thank you, Ms. Lofgren, very much. I now recognize the ranking chairman of the full committee, Mr. Lucas.
Thank you, Mr. Chairman. Mr. Schingler, your company has been around for a decade, and you've partnered with NASA and other federal agencies during that period. How has NASA's approach to commercial providers changed over that time?
Thank you for the question. Thank you for the question. And honestly, it might be a bit of my heritage, but NASA is the most forward-leaning of all the government agencies in partnering with commercial companies. You can see this picture behind me is actually taken from an astronaut from the International Space Station in 2014, when we first launched our first fleet of 28 satellites. And over time, as we mentioned with the commercial smallsat data pilot program, now hopefully an upcoming operational capability is extremely promising. And then also, as Riley was mentioning, with the Carbon Mapper program, we are at the scale and support right now that we are looking to transfer some of the cutting edge technology from NASA that can then be applied for an operational capability. And that's what Carbon Mapper is all about. So NASA is only accelerating with its adoption and partnership with all that America has to provide in not only solving additional climate change challenges, but then also bringing it to the rest of society.
Well, continuing down this vein, how can the committee help spur increased partnerships between NASA and the commercial data providers in the future?
Well, my main recommendation is for this committee in particular, is to put into statute for the commercial small sat data acquisition program and to robustly fund it. There are many companies just like Planet. There are about a half dozen or so that are operational and about 24 or so that are coming up. The more that governments can partner with emerging commercial players, those commercial players, if they have a customer, they listen to them. They want to please them, and they will upgrade their services to meet their needs. And so I think by creating that program and then opening up the aperture to allow for NASA scientists to find scientific utility rather than to prove it from a procurement strategy is part of how we can think through creating new program offices. Continuing
with you, Schingler, NASA has for years partnered with other agencies. I think of USGS and NOAA on Earth observation activities. Currently, those partnerships consist of NASA developing new satellites and instruments, which are then operated by the other agencies. Do you still view this as the most productive and cost-effective model?
I think there are definitely scientific signatures that need to be collected that can only be done by national labs and that are necessary, and not just for science, but also for commercial. We use some of the signatures that we get from NASA and NOAA satellites for interoperability for our data sources. However, many of our legacy programs can be upgraded to go further out and to do the harder thing, and to allow for operational services to then be provided by commercial players such as Planet and others. So I do think that there's a great opportunity to look at program offices, not just for the specific data that they're trying to do, but what is that signal that they're actually sending to the market in order to stimulate innovation and to think about it across industry, academia, and government programs together.
Well, along that line, from your perspective, what kind of adjustments in the model that we're using now? Mechanically, what do we need to look at on this committee to improve that model along the lines of what you were discussing?
Well, I have two suggestions. One, besides putting into statute the commercial small sat data program, one suggestion is to have a portion of that that allows for NASA scientists to innovate with whatever is out there. And so that is one way to accelerate that. And the second is to partner with prototypes. Instead of doing operational missions in science grade PI-led programs, to think through and expand in particular, Earth Science Venture Program to allow for there to be public-private partnerships that then allow for much more of these hosted payloads to happen on not just about once every 2 years and a new mission once every 2 years, but to allow for that to happen on the order of 6 months. The industry is there ready to partner with NASA on this, and this is something that NASA and this committee should consider.
Absolutely. Thank you very much. Mr. Chairman, my time's about to expire. I yield back.
Thank you, Mr. Lucas, very much. And I recognize the gentleman from Florida, Governor Charlie Crist.
Thank you, Mr. Chairman, and thank you to the witnesses for being with us today. Under the Biden administration, NASA's science missions will play a critical role in informing the federal government's efforts to combat climate change. One of the most significant climate change impacts that Florida faces is the increasing frequency of severe weather, specifically hurricanes and as well as other tropical storms. Dr. St. Germain, could you discuss the role that NASA's Earth observations play in weather forecasting? And could the prediction of these observations be used to improve weather prediction on capabilities?
Thank you so much for the question. So, of course, as you know, NASA partners with NOAA to build NOAA's operational weather satellites. And we also partner with NOAA and other agencies to advance modeling and data assimilation. That happens primarily through the Joint Center for Satellite Data Assimilation. We augment those observations and capabilities with small sat technologies like Cygnus, RainCube, Tempest-D. These are all small demonstration missions that brought additional data to bear and are particularly interesting for tropical cyclones and point to a path of more affordable observations. In addition to that, about a third of our 45 disaster activations last year were associated with weather and in particular tropical cyclones. So, and then all of that, of course, is underpinned by our research and analysis program in weather and atmospheric dynamics. So across our whole Earth Science division, from technology to science to exploratory science to applied science, we are supporting the advancement of weather prediction and warning capability.
Thank you. The 2020 Atlantic hurricane season was the most active and the fifth costliest Atlantic hurricane season on record. Again, to you, Dr. St. Germain. Given the increase in frequency of severe weather events and the resulting risk to human life and infrastructure, can you discuss what the next generation of sensing and imaging capabilities looks like, especially as they relate to weather prediction?
Yes. So, of course, as you know, NOAA is formulating its next generation of weather observation capabilities, particularly in geostationary orbit, and NASA's future observing systems will be aligned with the recommendations from our decadal survey, which, of course, characterized the most important observations to make to achieve both climate change, advanced climate change understanding, as well as weather related understanding. So the primary missions associated with the decadal survey are, of course, the aerosols convection, clouds convection and precipitation observations. Those will be looking to move forward on to answer some of those really fundamental questions. And actually, I think probably Dr. Schmidt may have something to say on this topic as well.
Doctor?
No, I think you actually covered it pretty well.
Okay.
Sorry.
Okay.
Would any other of the panelists like to comment on this?
When it does come to increasing our understanding of extreme weather, it is a combination of a variety of data sets, different types of microwave sounders from space, also ground-based, and in addition to land monitoring systems. So Landsat models are included in that, and it is something that NOAA should look at, which is including in other types of land monitoring data sensors to allow for us to have better models. The other thing that is extremely promising about this is the power of cloud computing and machine learning on top of these aggregate disparate data sets together that allow for us to have a better understanding for what's about to happen. So as these data are all activated and interoperable with one another, we will be able to better anticipate what's about to happen, not just for weather, but also for other types of land use change.
Great. Thank you very much. I appreciate that. I see my time's about to expire, Mr. Chairman. Thank you. I yield back.
Thank you, Congressman Christ. Now let me recognize the Congressman from Cape Canaveral, Mr. Posey.
Thank you very much, Chairman Beyer, and appreciate you holding this hearing on the current roles and future opportunities for NASA's Earth Science. Mr. Schingler, China is aggressively pursuing remote sensing capabilities and offering them on the commercial market. Just wondering what we can do to ensure that we remain the leader in commercial remote sensing.
Thank you for the question. Over the last 5 years, as I mentioned in my testimony, my verbal statement, there is a renaissance that's happening in Earth observation, and it has been led by U.S. companies and companies across Europe. Over the last 4 years, that has been eclipsed by a number of Chinese companies that are very well funded and very well supported across academia and the Chinese government. We are competing in a global marketplace, and what makes American entrepreneurship great is that we look for global products in market-making industries, bring them to society, and then we upgrade them, and it's trusted. So I do think that the foundation that we have inside American industry will thrive and grow this new frontier economy. But it definitely is a challenge. Some of the things that are being brought up right now is to really embrace U.S. commercial industry and purchasing the services that exist today, knowing that there's a partnership for it to be upgraded over time. And this is something that we have not seen fully embraced inside the DoD and the IC community. And I can say again that NASA has been an early adopter into this, and we look forward for this to expand. But that's the main thing, is to partner, is to be a lighthouse customer, not the only customer, but to be a customer of U.S. commercial industry. And they will rise up and they will solve the needs of tomorrow.
Thank you very much, Mr. Schingler. Dr. St. Germain, I'm particularly worried about China, as many of us are, through state-owned enterprises investing in new private climate satellite companies in order to influence the information they receive. Can you tell us how NASA might not only validate the new data coming from these non-government satellites, but also review any intentional or unintentional biases that could emerge from them?
Thank you for the question. So NASA doesn't have any direct bilateral collaboration or work underway with China. But we do have a lot of multinational partnership work underway. And in fact, we lead multinational organizations such as the Committee on Earth Observations. And our primary focus in those leadership roles is to expand and really underscore open science and the trust and transparency that goes into the understanding those measurements and their scientific integrity. And so I think where we can really contribute here is leading in that international arena, along with our commercial partners, to underscore the importance of transparency and trust in the data that we're using, and create that expectation internationally.
Might I add something to that answer?
Absolutely.
One of the key issues with any new source of data is that every new source of data has its own special characteristics. One might call it bias, but they all have special characteristics as a function of their orbits, their instruments, and how often they're reporting. When you put that into a data assimilation system, the physics that's been embedded within that system tells us whether things are consistent or whether things are coherent. And so these systems will tend to reject data that is too biased, that doesn't fit into how the assimilation is thinking that things should work. And we're able to detect instruments that are malfunctioning. We're able to detect instruments that are not properly calibrated by embedding them within a larger data assimilation system. And that would be true for data from any source.
Thank you very much. I see my time has expired. I appreciate it, Mr. Chairman. I yield back.
Thank you, Mr. Posey. Mr. Posey, I'm going to ask the second round of questions if you care to hang in for that. So you're most welcome to. Okay. So let me, Mr. Duren, you wrote that there's a real problem in data latency, that you have these wonderful people collecting data and it takes 1 to 3 years until it's delivered in publishing time. How do we get over that? You say we need more streamlined frameworks to effectively support decision making, but the data latency is an obstacle.
Yes, sir. Of course, things vary, but it's generally the case that when it comes to greenhouse gas emission estimation in general, that current frameworks fall into one of two. Bucket one is conventional greenhouse gas inventories that are compiled typically by nation states, but increasingly some subnational jurisdictions. And those methods use fairly tried and true publicly available data that we call activity data, things like how many vehicle miles traveled, how many cows, how much coal is bought and sold. And then these regulatory agencies like the Environmental Protection Agency apply emission factors to generate an annually aggregated, nationally aggregated accounting of all greenhouse gas emissions by sector and by gas. As you can imagine, that process takes time. In many cases, those inventories lag by a couple of years. And so they're trying to get it right, but they're not necessarily fast. And the other bucket are experimental advanced science-based measurements using atmospheric measurements from a variety of techniques, not just satellites, but surface measurements. And NASA and many other agencies, NOAA, and experts around the world in academia are advancing that. NASA's own carbon monitoring system is pioneering that. Many projects that are advancing that, but these are experimental in nature, and to the extent that they do produce data more quickly, they don't do it for very long. They typically last about 3 years, these pilot projects, and they also tend to be very focused in individual areas. So the need to operationalize climate data, in particular greenhouse gas data, means also addressing this latency problem. And there are ways to accelerate it, mainly by providing some engineering and machine learning and automation and software engineering to speed these processes up and most importantly, sustain them so they're not just one-off research programs. So we need to span the research to operations gap here.
Great. Thank you very much.
Chairman
Mr. Schingler.
Yes, please.
Go ahead.
May I comment on this? So the latency is really all about speed to information, helping people make better decisions. And I mean, we are so connected here. We get pushed information constantly. And really, if you unpack that infrastructure that's put in place across cell towers and so forth, that infrastructure is now going up into space, right? So we will have, over the next few years, real-time connectivity via space-based orbiting assets. We will have satellites that then in space take pictures of the Earth and tap into that so that you'll have real-time understanding of what's happened. The other major trend that's happening is something that is in the Internet of Things world, or edge computing, which is where you collect information, you do some compute right where it is. So for things that happen that have some public interest, so for instance, in Riley's program at Carbon Mapper, if there is a methane leak, which is really toxic for public health, that could be detected on board and immediately inform the first responder. And so these are some of the things that are happening today across infrastructure that's going into space that allows for real-time understanding of the planet at the speed of decision-making for public health, but then also for commerce.
Thank you very much. And Dr. St. Germain, lots to talk about all the different data. What's NASA's policy on NASA-supported Earth science data in terms of archiving, in terms of free and open access, and availability to the public, including raw data? And how do you maintain that policy, including conformance to the World Meteorological Organization data policies with our non-federal partners?
Thank you for the question. Yes, NASA has a full and open science data policy. All of our data are freely available, and we're really pushing to advance that with not just availability, but real discoverability, and putting the data in the same ecosystem as the computation capability and the models and the applications. So that's all part of our plan to accelerate our delivery of actionable information. In the context of commercial data, of course, we negotiate with the commercial data provider on the terms of a user license. And that can, in the early going, in the NASA commercial data pilot program, that was limited to NASA users only. But of course, when we're talking about open science, we want to make sure that other non-NASA funded scientists and other agencies have access. So we're working to standardize a set of options for user licenses that can allow us to distribute that data more broadly.
Great. Thank you very much. Mr. Posey, the floor is again yours for questions.
Thank you. Thank you very much, Mr. Chairman. I appreciate the second round. Dr. St. Germain, a real fear is, I believe, that that private satellite companies could possibly target facilities, industries, competitors, whatever, while ignoring other areas, and then selectively release information. You know, what would prevent these companies from cherry picking observations to gain an upper leg over others that puts their interest first and skewing the data that decision makers receive and the public receives?
Let's see. So for the data that that NASA acquires and
no, we're going back to China, back to the China funded companies. I'm sorry.
Okay. So I think that is a question that is probably more would be more important for operational agencies that could make use of Chinese data. But as I said earlier, we at NASA don't buy Chinese data, and we don't have any ongoing bilateral arrangements to use Chinese data.
Representative Posey,
Dr. Schmidt, others want to weigh in here?
Can I answer that? So I think, yeah, Congressman, I think this is why Robbie and I and others, and I know our NASA colleagues would agree that it's important to have a global system of systems that's not limited to a unilateral actor. Environmental data from Earth observations is too important. Wrong, either intentionally or through bias or by getting it wrong because the science or the technology is wrong. So I think we are on the verge of seeing an emergent global observing system of systems that includes observations not just by NASA, but also their international partner agencies in Europe and Japan, in not just China, and also in commercial space. And so I think the best way to tackle the question you're raising is really for an open skies policy with multiple independent observations that can cross-check and validate each other and build public confidence that no single system is introducing bias, either intentional or otherwise. And I think a good question for this subcommittee is, what's the right role of NASA and federal agencies to help enable that, to make it work?
Well, listen, I appreciate the good answers. Dr. Schmidt, you want to weigh in?
I think that's very. I mean, what Riley said was good. Multiple views of the same place and time from multiple instruments gives us a coherent and consistent story about what's happening, and that needs to be multi-instrument, multi-platform, and multi-companies and multi-sources of that data. And I think the more that we build an infrastructure that allows that data to all be kind of part of one thing, then we'll be able to see things in real time that are anomalous or not.
And Congressman, to the commercial systems out there are also critically important for that overall multi-data source observation that is secure. So, for instance, geoassurance is what this is called inside of the geospatial intelligence community. And if you have provenance of how you built your satellite and putting it up into space, you know that it's quite secure. That connection can also be secure. And to have pixel level provenance builds trust that what you're capturing is truth. And as a commercial company that abides by jurisprudence in the rule of law, getting all of society on a common operating picture so that bad actors can be seen and light can be shown, it allows for the fourth estate, media, think tanks, and science organizations to actually validate and hold truth to power for those who are doing things that are different from what they're saying. So there is something that is really, really powerful about our sector in remote sensing to provide that level of transparency to allow for us to have a more secure and sustainable world.
Now, it's like the news, really. We want it to be as accurate as possible, and that's not always the case. Mr. Chairman, I want to thank you again for holding this hearing. Very interesting, good information. Thank you, witnesses, for your input. We really do appreciate it. Thank you.
And thank you, Congressman Posey. I'm going to, since we have these wonderful people and we don't want them to go to lunch, I'm going to fire one more set of questions at them. which you're welcome to stay if you like, but I understand there are other meetings too. So Dr. Robbie Schingler, you spoke specifically about U.S. federal agencies prioritizing commercial data buys, and I guess frustrated with DoD and the IC. But you also talked about remote sensing regulations, launch payload regulations, orbital debris regulations, spectrum regulations, all playing a critical role in our commercial sector's ability to participate internationally. Do you think that we are over-regulated? The regulations have gone too far? The commercial industry not had sufficient input in the development of those regulations? Have we right-sized it yet?
Thank you, Chairman Beyer. There are two questions in there. The first one around the U.S. Defense Department and the intelligence community. I think it's important to note that the National Reconnaissance Office more or less created Earth observation. And they created extraordinary technologies in space that allowed for our nation to understand what's happening in an offset that other people did not know how they actually did it. Just extraordinary stuff. So I do not want to state anything otherwise. However, what has happened is that when you have a disruptive capability, which Planet and others are a part of, it isn't the way in which people are used to the performance of a system. But a new axis can come out. So for instance, timeliness, looking for the unknown unknowns, and those types of activities is just not the way that it's been tooled up. So there has been some frustration on our part because we want the government to lean in and find mission utility and to actually be a partner for us to upgrade those services to support them. So I just want to more or less state is that we're doing the best that we can as a commercial partner. And also, I do believe that the government program offices are also doing the best they can within their constraints. But that's where oversight can come in to really help see, are there any blind spots that we have in our overall strategies? So that's number one. Number two, about regulation. Regulation is, I actually said this at a conference a couple of years ago, but it's actually like a really hot place to be in because you're shaping markets. You don't want to go too far out in front, but you also don't want to hold back innovation. And so it's something that that is a constant dialogue. So having these advisory committees really does support and help. But of the biggest challenges that we have today, it is going to be RF remote frequency challenges, sharing of that, as well as orbital debris. And we do need, as a global community, and it can be led by the United States, a space traffic management capability that allows for freedom of operate and space security. This is going to be a challenge over the coming decades, and it's something that we should not wait in order to come up with a good solution. So I would say in some cases there are some constraints around industry, probably for some very good reasons, but some might be for legacy reasons. And so that's where advisory committees can come in to try to show those blind spots to the regulators.
Great, thank you very much. Mr. Duren and Mr. Schingler, the importance of free, unrestricted and open data sharing as part of the federal government's research and development activity is paramount. So is your data, the raw data in your agreements in contracts with NASA, either through the commercial small sat data acquisition program or arrangements for Carbon Mapper, available to the public freely, openly, no restrictions?
Yeah, I'll start, and then I'm sure Robbie can chime in. So Carbon Mapper is a nonprofit, and we have a public good mission to make methane and CO2 data freely and publicly available globally. And so the approach that we've established is that Carbon Mapper will stand up a global data portal that maintains a running stream of methane and CO2 data to the public that includes the best possible quality control and uncertainty quantification. That is also underpinned by independent validation by the California Air Resources Board. We didn't talk about it in detail, but California's role in our public-private partnership is they will get access to all of the methane and CO2 data immediately, and they'll send people out in the field to do ground-based follow-up on it, if you will, to help certify it and validate it so that it has broader trust globally and ideally adoption. The other thing to understand about the public-private partnership and the way that our vision of how to monetize the build-out and sustainment of this system is it is dual use. So there is a commercial arm to this, and it's enabled by the NASA technology. The imaging spectrometers that were designed by NASA JPL actually cover the full spectral range of the visible wavelengths and the shortwave infrared. And that allows us not just to detect and quantify methane and CO2 emissions. There are dozens of other environmental indicators on the land and in the oceans that Planet is free to commercialize. And so it's this dual use program where Planet can commercialize other applications while serving Carbon Mapper's public good mission and actually sustain the program through a revenue share back to the nonprofit is part of what's innovative about this. And we think it will help address one of the challenges we face with federal programs, and that is continuity. How do you keep these observations going once you start them? I guess I'll now hand it over to Robbie, and maybe you can add to that.
Yeah, I'm super excited about this program. It is a really unique public-private partnership. And so hats off to Riley and to Karen for actually pulling this together. It's not just continuity, but it's upgradability, right? It's collecting the needed information that's needed, not just for today that we know of, but also where things are actually going. An example of this around open data versus commercializable data are a couple of programs that we pioneered in the last couple of years. And it's under a broad rubric that we call digital public goods. And so one example is what we've done with Norway. So Norway has been a long-time supporter of a UN program to reduce emissions of deforestation. And we entered into a project with them after 4 years of validation that opens up a monthly cloud-free base map of 64 tropical countries around the world that's available to the forestry programs inside all of those countries to allow for people to be on a common operating picture to curb deforestation. And importantly, it allows for those nations to get access to payments from the World Bank for not chopping down their forests. And so this is a good example of it's all based on our commercial data. We created a higher order data product and then a specific license to allow for public benefit to happen, while we also still have the ability to sell similar types of data, put it into a different format, then to serve those to our over 600 enterprise customers that we have around the world. So that's one specific example that we have done successfully. And that model came into the formulation of Carbon Mapper as a nonprofit, where we deliver the data to Carbon Mapper, and then they deliver a higher order data product, almost like a weather service for methane and CO2 emissions to the public as a digital public good.
Thank you very much. It's very, very encouraging. So let me wrap up with one last question for Dr. Schmidt, although you're welcome to add to that too. You're the Senior Advisor on Climate for the NASA Administrator. So you're the very pinnacle of our climate change efforts. Is there any hope? Do we have any shot at keeping it 1.5% centigrade by 2050 or the end of the century?
1.5 degrees centigrade. That's a very hard question. There are pathways that would keep us below that by the end of the century. There aren't that many pathways that prevent us from going above that in the short term because of the inertia in both the climate system, the oceans, and in our societal responses. But there are a lot of activities going on, and there are a lot of very, very promising activities at all levels, the federal, regional, local, and international level that are pushing us in that direction. The targets and the plans that people have put in through the Paris agreements for their nationally determined contributions to cutting emissions are getting closer to the 2 degrees target, and the ratchet mechanism that was built into the Paris Agreement seems to be working. People are seeing what can be achieved and then trying to look into doing better. So I don't think it's totally hopeless, but I think it is clear that we do need to prepare for more climate change to come. The exact number, speaking personally, the exact number that we end up with is not, nothing particularly terrible happens if you go from 1.5 to 1.55 or 1.6. But what we know is that the impacts are ratcheting up, and they are increasing exponentially as we continue to warm the planet. And so we're always going to be in a situation where we could be doing better. But it's never the case that we should be giving up on making better decisions.
Mr. Duren?
I just wanted to chime in quickly. We get this question a lot, especially on the greenhouse gas mitigation topic. Is it too late? What I would say is there is still time and an urgent need to act quickly. The window is closing. And you can look at the Biden administration's recent commitment to cut, U.S. greenhouse gas emissions by 50% by the end of this decade. We're well into this decade already. I do think that it is an all hands on deck moment for not just the federal government, but all government branches, private sector, and civil society. And it's not too late to act, but I think we could do a lot more as a society to take advantage of all the resources at our disposal. And I know we've been talking in this hearing mainly about our Earth observations and NASA data, but I want to add another aspect of NASA that is part of the federal capability, and that is NASA's engineering and program management capability. You mentioned in your opening statement, moonshot. That's brought up frequently in regards to the climate response of this country and others. And I think that is a minimum an analogy of what kind of effort and mobilization is needed. And I think there's more of it can and should be done in engaging all of the resources of the federal government that right now are constrained by institutional limitations. NASA fits over here in this part of the ecosystem, and the other agencies do that. And I realize that it's unrealistic to call for a whole-scale reorganization of government, but I think there is creativity needed and resources that are still untapped within agencies like NASA that can do more than deliver satellites. And so that's something probably beyond the scope of this hearing, but I just want to throw that out there, is there's more we could and should be doing.
And to echo on that, Chairman Beyer, this is an opportunity for the U.S. government to provide leadership across the entire federal government, just like what Riley is saying. We have the National Space Council that should have a strong voice for climate. It should encourage the Office of Space Commerce within the Department of Commerce, the Climate Envoy, and commercial players to be part of this overall solution. It is a system of systems. NASA has a systems engineering approach to it. NASA's been playing with this data, understanding climate as it has happened. And that technology can really be useful for us to understand what we can do about it. The most encouraging thing I see in tackling the problems of today is the fact that Larry Fink, who's the CEO of BlackRock, who has over $6 trillion under management, in his last 3 statements have said that climate risk is investment risk. If we take a look at the global markets and the amount of money that is going toward so-called ESG funds, or environmental, social, and governance funds, the market is shifting. We need to ride that wave and shift it in order for us to live sustainably on this planet. So this is a all hands on deck, and it's not just government, it is industry. Those are the incentives that will actually drive consumer behavior and corporate behavior. So I'm encouraged by it, but we do need to accelerate our activities.
Well, I think for anyone who's listened to the last hour and a half plus, they have to be encouraged by the capabilities of our 4 witnesses today and all the things that you're doing. So thank you very, very much for being here. Thank you for your good work on behalf of all of humanity. And we hope you will come back and talk with us often. So let me just say that the record will remain open for 2 weeks for additional statements from the members and for any additional questions the committee may ask of the witnesses. So if there's no objection, the witnesses are excused and this hearing is now concluded. Thank you and have a great May. We'll see you soon.